We're going to spend a good bit of time talking about systems of equations with three variables. I'm going to be doing a lot of handwriting in this problem because I think it's easier for you to see the problems being worked out. You all should have had exposure in the past to using elimination to solve a system of two equations. We're going to use elimination again, except now there's going to be three equations with three variables. You're going to use that same thing that you did with two equations in that you're going to multiply one of the equations by a non-zero number. You're going to do that in order that the coefficients of one of the variables will be opposite in sign, but yet the same absolute value. So like a 4x and a negative 4x. You're going to add that equation that you've multiplied through by a number to another equation. The equation that you add it to is the one that's replaced. So see my red check mark up here. I'll put another red check mark. Think about when we do this process, if you've multiplied an equation by a number, you've locked it in place. That's not the one that's going to disappear. It's going to be the other equation that it's added to that will disappear. Let's go through this. Here's a system of equations with three unknowns. So I'm going to look at this, and the first thing I'm going to try to do is eliminate the x variable, from these top two equations. So to do that, I've got to multiply the second equation by -2. Automatically now, I've locked that equation in place. That equation's going to become -2x plus 2y minus 4z equals +6, because -3 times -2 is +6. Now we're going to go ahead and combine those two equations. So we end up with -y minus 3z equals 5. This equation here is gone now. The one that stays is the one that we multiplied by -2. So what we've got now is this equation, and this equation. So let's go ahead and write that on a new slide. Now I'm going to go through and eliminate x again. So to do that, I've got to multiply this equation by -3. I'm going to work with my top two equations again. So it's that top one that's locked in place. It becomes -3x plus 3y minus 6z equals 9. So now we're going to combine those two equations. And we've got 4y minus 7z equals 18. Okay? The equation that's locked in place is the one that had the -3 next to it. So this one is gone. So the three equations that are left are this top one. We'll call this equation 2. And now we've got equation 3. So let's clean up this page and rewrite it. Now I've gotten two of the equations to just have y's and z's. So I can now work with that to solve for one of the variables. So looking at these two equations here, if I want to eliminate, I'm going to multiply this equation here by 4. It becomes -4y minus 12z equals 20. So when we combine these two now, got these two here, we're going to end up with -19z equals 38. The one that's locked in place is the one that's got the red number next to it. So this one is gone. Now we can go ahead and solve this equation for z. by dividing both sides by negative 19. So z is negative 2. So we've figured out one of them. Let's now rewrite what we've got. Recall that we've got this equation still in place, this equation still in place, and we know that now z is negative 2. If we know that z is negative 2, now we can plug that in to this equation to figure out what y is. So we've got negative y minus 3, z is negative 2, equals 5, or negative y plus 6 equals 5. Subtract 6 from both sides. So negative y is equal to negative 1, or y is positive 1. So we know y, we know z, and now we can plug it in to figure out x. So let's go ahead and make the final substitution. We've got x minus y is 1 plus 2, z is negative 2 equals negative 3. So we've got x minus 1 minus 4 equals negative 3, or x minus 5 equals negative 3, and if we add 5 to both sides, we end up with x is 2. Let's try another example. So in this case, we already have two equations with just two unknowns. So let's multiply through this equation by negative 1. So that equation is going to become negative y plus 2z equals 1. And we're going to combine those together, and it's going to become 7z equals 7. Remember, the one that's locked in place is the one with the number beside it, so that one is gone. We can go ahead right now and just solve this for z by dividing both sides by 7, so we know automatically that z is equal to 1. You can take that z is equal to 1 and you can plug it back in right into this equation to figure out y. So we're going to have y minus 2z being 1 equals negative 1, or y minus 2 equals negative 1. Add 2 to both sides. Y is equal to 1. Finally, you're going to take these two values and plug them in up here to equation 1. And when you do that, you're going to get x equals negative 1. I want you to try that on your own and see if you get x equals negative 1. These systems can also be solved by using something called a matrix. And all a matrix does is it eliminates the variables from the work that you're doing. So let's look at how that plays out. Here's your system of equations, and we're going to rewrite this so that it's a matrix. So what you're going to do is you're going to use a bracket, and we're going to take all of the coefficients and write them. So we've got 2, negative 3, and 1. I'm going to draw a line down, and on the other side of that line is where we put what's on the other side of the equal sign. So our next row is going to be 1, negative 1, 2, and on the other side is negative 3. And then we've got 3, 1, negative 1, and on the other side is a 9. There's our matrix. Your goal with the matrix is to end up with a diagonal of 1s that's actually going to be running right along this diagonal. And then what's going to end up sitting over in these spots that I'm going to underline in red should be zeros. So let's see what that looks like. Just by switching row 1 and row 2, which I'll write like this, I can get the 1 in the left-hand spot. So let's do that. Now the next thing I'm going to do is multiply row 1 by negative 2. We're going to add that to row 2, and it's going to go into row 2 because remember, whatever we've multiplied by gets to stay. So what I've done over here on the right-hand side is I've written out what happens when we multiply row 1 by negative 2. Those are the numbers that you get. That's what we're going to add to row 2. So row 1 stays. It's locked in place because we multiplied it by something. Row 2 is going to become 0. We're going to add 2 to negative 3, which gives us negative 1. We're going to add negative 4 to 1, which gives us negative 3. And we're going to add 6 to negative 1, which gives us 5. And I'm just going to rewrite the bottom row in there again. Now I'm going to do pretty much the same thing. I'm going to multiply row 1 by negative 3, but this time I'm going to add it to row 3, and so the answer is going to sit in row 3. Like I did up above, let's see what happens when we multiply that top row by negative 3. We get negative 3, 3, negative 6, and 9. And let's add that to row 3. When we add that to row 3, the answer that we get is the matrix that's sitting right here. So now we need to go through the process again to eliminate the 4. First thing that I'm going to do though is just multiply everything in row 2 by negative 1. So we're going to end up with 1, negative 1, 2. This one hasn't changed. But now I've got 0, positive 1, positive 3, negative 5, 0, 4, negative 7, and 18. So next thing we're going to do is multiply row 2 by negative 4 and add it to row 3, and it's going to go into row 3 because since we multiplied row 2 by something, it stays. So this becomes negative 4, negative 12, and positive 20. So let's go ahead and put the new matrix in place. And once you've gotten it to this point, this step here is easy to rectify because we're just going to go ahead and divide row 3 by negative 19. So that's going to become as our final step, we've got 1, negative 1, 2 with negative 3, 0, 1, 3, negative 5, 0, 0, 1, and on the other side of it's going to be negative 2. And now you can see that running along this diagonal here, we've got all 1s with everything to the left of it as 0. And at this point then you can do the algebra. This value here is always z, this value here is always y, and that value there is always x. So now I know that z is equal to negative 2. The equation that corresponds to row 2 is y plus 3z equals negative 5, and we'll plug the value of z in. And this equation here is x minus y plus 2z equals negative 3, and we'll plug in the values of y and z into that equation to solve for x. We can do this on a graphing calculator, so let me walk you through how to do that, and then we will have plenty of practice with this throughout the work that we do this week. So to access a matrix, you're going to hit the second button, followed by the x to the negative 1 button. You'll arrow to the right so that you can edit the matrices. You'll have to enter the number of rows and the number of columns. So you'll type that in. So in the problem that we just did, you'll count the solution as another column. So the one that we just did had 4 columns and 3 rows. So you'll enter those numbers into your calculator, just the coefficients. So your first row will read 2, negative 3, 1, negative 1. And I want you to do that for all 3 rows. Once your values are in, you're going to go ahead and again, you're going to select matrix. And then you're going to move over to math. And you're going to choose the one that's B colon R ref with the parentheses in the display. You're going to tell the calculator which matrix you're located in. In my case, I put mine into matrix A, so I would type an A in. To get that A to come up, you're going to have to go back into matrix. You're going to have to then go into A just by hitting enter, and A is then going to pop up on your screen. Close the parentheses and hit enter. When you do that, you'll actually end up with z equals -2 because you'll see 1 with a -2 sitting next to it, which indicates the value of z. Above that, you'll end up with y equals 1, and above that, you're going to end up with x equals 2. So the matrix is solved for you by using your graphing calculator. This section can be a little bit tricky, so I'm hoping that you've practiced with the problems that have popped up on your screen while you've been working through the video, and I really want to make sure that you get this homework done, and then we're going to move on to application problems.